All right, section 3.3, multiplication and division of whole numbers, is going to feel a lot like section 3.2. In 3.2, we were working with addition and subtraction. Now we're working with multiplication and division. But you're going to see a lot of the same flavor of things come up again. For example, the first thing we need to talk about is what in the world does multiplication mean? So I've kind of combined a couple of definitions that your books used into one definition because I thought it made it a little bit more cohesive. Multiplication for whole numbers says the following. If you have finite sets A and B, and if the n of A, that means the number of elements in set A is little a, the number of elements in set B is little b, if n does not equal 0 and you multiply n times A, that's the same thing as repeatedly adding something together n times. So this right here, there are n a's. So in other words, when you talk about saying 3 times 15, it means 15 plus 15 plus 15. The 15 is added together 3 times. Really, multiplication is just shorthand for addition. That's all it really is. It allows us to add more quickly. The second star that you see here is that when n is actually equal to 0, and we'll see this property pop up again, that when you do 0 times a, you get 0. It's actually called the 0 property. And the third one actually says, well, what happens if it's not just n? What if I actually have two sets, A and B, and I multiply them? Well, A times B is actually the number of things in something we've seen before. Do you remember what that A with the little cross and the B was called? It had a name. We called it the Cartesian product. And we created ordered pairs. It was back in chapter 2, right, where we had like 1, 2, and 1, 3, and 1, 4, and then we had other things. And so there was this property over there. And so one of the things that the property told us, and this is what happened back in then chapter 2 as well, is that if you multiply the number of items in set B times the number of items in set A, then you would actually get the same thing as the number of items in the Cartesian product, the number of ordered pairs. And so we're seeing this kind of come back up again in this section. All right, so the real one that we use and use quite a lot is this idea of repeated addition, and that's exactly where we're going to start with our models. So there are 3 models for multiplication. The first model is the repeated addition model. So here's an example. Giselle takes 3 tests every Friday. After 4 Fridays, how many tests has she taken? So, of course, this is asking us to multiply, right? 3 times 4. But it's doing it in such a way is that we recognize that it's saying that we're adding together the same number 4 times, right? So this is the number that's the same as taking 3 tests on this Friday, 3 tests the next Friday, 3 tests the next Friday, and 3 tests one more Friday. And so this is actually the same thing, of course, as 12 tests. Okay. Evidently, I ran out of space. 12 tests. Okay, that's repeated addition. We see this kind of language used a lot when you first start multiplication, this idea of repeated addition. All right, there's a couple more. The other 2 are very, very similar. The first one is the array model, and this in particular is used for sets. Minhu is baking cookies. He is able to place the dough 3 cookies wide and 6 cookies long on his pan. How many cookies will his pan hold? So this one has a really good visual to go with it. So we're going to actually draw this. Well, I don't want the same color I had last time. Let's do... Okay, that's 6 cookies long. And I'm supposed to be able to go 3 cookies wide, right? So here's 2 cookies wide. And here is 3 cookies wide. Okay. So you have this image of something that's in rows and columns. And if you take a look, then of course, because the problem was set up this way, there's 3 wide, and here's 6 long. And this is telling me then that 3 times 6 is the number that if we counted all these cookies we would get. And if you do count them, what do you get? You get 12. I mean, 12, sorry, you get 18. Say the wrong thing. 18 cookies. Let me write that down too. But that's really not repeated addition, right? It's an array. It's a visual image that makes sense in terms of an array. It's somewhat different than the problem before, both multiplication, but it's not quite the same thing. All right, the last one is very similar to array, but you'll notice that this is supposed to be used for measurement. Did I get yours written right on your paper? I did. I didn't get it right on my paper or on my screen. This should say used for measurement. All right, Alexis is planting a garden. She has a space that is 5 feet wide and 7 feet long. How much area does she have in which to plant? Okay, so you'll notice that you're measuring how long something is, and this is in feet, kind of like the miles problem we did before with somebody going to the mall and things like that, right? So we are measuring something, and so the image that goes with this is not going to actually look very much like an array. It would be much more likely for it to look like a what shape? What would seem reasonable here? A rectangle, yeah. So she's got a rectangle going on, and in our rectangle we can draw rows and columns if it helps us. I'm not going to just because of time's sake right now, but I'm supposed to have a space that's 5 feet wide, and I've made mine the vertical feet, and then it's 7 feet long. So my length is actually across my screen, my 7 feet. And if I broke this apart and drew, 7 columns, basically, and I drew 5 rows, and I counted all the little bitty boxes, I would actually be doing the same thing as taking 7 times 5. And what would I be getting? 35. And we could actually write down that this then is feet squared, right? Okay, so we have feet squared when we do that because it's feet times feet. So we're doing this in terms of a measurement picture instead. Does it feel a lot like array, though? It should, right? You're just doing it with something where you're doing a grid instead of doing individual units where you count them. Okay? All right. We're going to pause right here.